All right, guys, looking at this, when we talk about graphs of logarithmic functions, all right, this is our exponential function here in blue. You guys see it? This is our exponential function. We talk about the domain of our exponential being, for exponential, our domain is what? Yep, negative infinity, positive infinity. For my parent graph, we're talking about the parent graph, your range would be from 0 to infinity. It's whatever the vertical shift is. It's dependent upon the vertical shift, but in this case, it's 0 to infinity. My y-intercept is at, right here, at 0, 1. And I have a horizontal asymptote at y equals 0, right? That's our exponential graph. Your horizontal asymptote in your domain depends upon the vertical shifts up and down. So when we talk here about log functions, I told you guys at the very beginning when we talked about this that logs and exponentials were what of each other? Inverses. So everything that you know about exponential applies to logs, just opposite. If I'm talking about domain and range for a log function, what do you think if domains, if my x values are negative infinity to positive infinity for exponential, what do you think the range is for logs? Negative infinity to positive infinity. Your x's and y's switch. So in this case, my domain would be left to right, 0 to infinity for my parent function. Do you see how the x and y values from exponential to logs switches? The same thing's going to happen instead of an y-intercept that we look for in an exponential function. What kind of an intercept do you think we look for the log graph? X-intercept. It's going to be at 1, 0 for the parent function. Instead of a horizontal asymptote that your graph gets really, really close to a horizontal line but doesn't touch it, what kind of an asymptote do you think you have with a log? What kind of an asymptote? If you have a horizontal one for exponential, what do you think you have for logs? Vertical. Yep. It's going to be at x equals. So it's the same concept, but everything just switches. Okay, if you look at this next slide, it tells you basically the same thing. This is how you find everything. All right, the log function reverses the domain and range of the exponential because they're inverses of each other. Your range for your log function is always negative infinity to positive infinity. For the exponential, your domain is negative infinity to positive infinity. They switch. In order to find the domain, to find your x values, it tells you right here, you set the parenthesis equal to 0. You'll see what I mean by that in a second. And then to find the x-intercept, just like you would if you were doing anything algebraically, finding x and y-intercepts for cubic functions or quadratics or anything like that, you plug 0 in. So if you're finding the y-intercept, you plug in 0 for x. If you find the x-intercept, you plug in 0 for y.
So what switches for the range? Like how does it switch?
For an exponential function, right? Your domain is all real numbers. I don't know what in the world that I'm writing. Negative infinity to positive infinity. Your range for exponential depends on, we'll call it the vertical shift, up and down. That's also what your horizontal asymptote is. It's your vertical shift up and down. And then you're going to have a y-intercept. Okay, with an exponential function, domain is negative infinity, positive infinity. Your range is dependent upon your graph moving up and down. Your horizontal asymptote is that horizontal line that your graph gets really close to, and you're going to have a y-intercept. When we talk about logs, it's the opposite. Your domain and range, your range in this case is negative infinity to positive infinity. Your domain depends on your horizontal shift. That's your left and right. Instead of having a horizontal asymptote, you have a vertical asymptote.
What if you switch, like for them to give you a formula for log and then you switch it to exponential? Could you do that?
I mean, you'd have to change the whole function. I'll show you in a second. And then you're going to have an X-intercept. All right, so look, this is kind of like, this is a good little thing to think about. Exponentials, we worry about them moving up and down. They do move left and right, but the parent function that we're worried about to figure all this stuff out depends on our vertical shift for our range and our asymptote. Our domain's always negative infinity to positive infinity, and we're going to be worried about y-intercepts. Your log function, your range is the one that's always negative infinity to positive infinity. And your domain and your vertical asymptote is going to depend on your shifting left and right. And instead of a y, we look for an x.
For the vertical asymptote, it's left and right?
Because your vertical asymptote is going to be a vertical line. So however much the function shifts left or right, that's what's going to move this line this way or that way. Alex?
What does it say for log depends, like for the domain?
Horizontal shift. And we're going to go over a couple of these so you guys will see. You have a web assigned tonight. Any web assigned questions you guys have for tomorrow, I'll answer in class. Everybody at home, you okay?
Yeah. Good.
Thank you to my 2 home Zoom students. My other 25. What are you guys doing? Let's move on. Same transformations that we've talked about with every single function, whether it be linear, quadratic, cubic, rational. All of our transformations stay the same. Guys, look, if you have a logarithmic function, you know it's a logarithmic because it says log. If you're adding or subtracting something to the end, that's our vertical shifts up and down. Right? Log 6 of x plus 4 means I go up 4. Log 6 of x minus 7 means I move down 7. Look at the difference here. Just like we did with our quadratics when we had quantity x minus 6, quantity squared, whatever. If you're moving left and right, it's going to be inside the parenthesis with the x. This is our horizontal shifts. And it's always the opposite of what we think. Right? Vertical shifts are up and down. Horizontals left and right, depending upon where it is. If you have plus or minus at the very end of your function, it moves up or down. If you have a plus or minus inside parentheses with the x, it's going to move left and right. If you have a negative that's out in front here, what does a negative out in front mean?
It's up or down?
It's a reflection where?
On the x.
Over x, good. If you have a negative inside the parentheses, where it happens to be with the x, it's going to reflect over y. Good. Same stuff you guys have known. All right, we talk about our stretches and shrinks. If there's a whole number or a number that's between 0 and 1 out in front, this is our vertical stretches and shrink, compression, however you want to say it. And then if you have a number here with the x inside, that's your horizontal. Remember, anything with the x affects the horizontal stretch and shrink. So on your quiz, and again, I'm going to give you some practice problems, but on your quiz, I'm going to give you a couple functions. I'm going to say, tell me all the transformations. You have to tell me that it moves up 6, left, whatever, reflects over x, reflects over y, depending upon where the numbers and the negatives are. And again, we're going to go over some practice problems in a second. Everybody at home okay? If this was the whole number 3, or 1/3, if it was a whole number 3, it'd be a vertical stretch by a factor of 3. If it was the fraction 1/3, it'd be a vertical shrink. If you have something inside here, like if it said log 7 of 2x, that's inside with the x, right? So it's going to be a horizontal, and you would think it was going to be a stretch because it's the number's bigger than 1, but it's actually anything with the x is always the opposite of what we think. So it would be a horizontal compression of 1/2. Anything that's with the x is the opposite. If it says x plus 2, that means you'd think it moves right, but it goes left. If you have a negative with the x, you'd think it would reflect over the x, but it actually is over the y. Anything that's with the x inside the parentheses is always the opposite of what you would naturally think in your head.
All right, thank you, Ms. Miller.
Sure, we're going to do a bunch of examples, I promise. All right, we're going to do this graph together. We're going to do it by hand. We're going to graph both of them. Uh-huh.
Did you say that it would be 1/2?
Uh-huh. It flips.
Oh, okay.
All right, we're going to graph both of these, right? Because exponential and logs are inverses of each other, is what we said, correct? Yes? So you guys, right now, if I said to you, make a table of values and graph that and not use a calculator, you guys would have no idea how to do it because you cannot find log 3 of -2 or whatever. So what you would do in this case, which we are not asking you to do this on the quiz, I just want to visually show you what this looks like. You'd have to graph the exponential first. So if I graph my exponential function, 3 to the x, right? I'm going to use -2, -1, 0, 1, and 2. When I plug in -2 into 3 to the x, it's 1 over 3 squared, which is 1/9. You guys agree? Okay. When I plug in -1, what that means is 1 over 3, so it's 1/3. When I plug in 0, 3 to the 0 power is 1. When I plug in 1, 3 to the first power is 3. And when I plug in 2, 3 to the second power is 9. Agreed? So if I'm going to graph this, at -2, I'm at 1/9. At -1, I'm at 1/3. At 0, I'm at 1. At 1, I'm at 3. And at 2, I'm up here around 9. So I draw my nice smooth curve. My function's going to get really close. Whoa. It's close enough. Pretend. It's going to get really close to the x-axis, but not touch it. Right? It doesn't move up or down. So what is my domain? When I have an exponential function, anytime I have an exponential function, guys, what is my domain? -infinity to +infinity. Good. In this case, my range is from where to where? What does my function get really, really, really close to but not touch? 0. Okay, so it's from 0 up to infinity. It does not include 0. That's why we have a parenthesis. What is my horizontal asymptote? What is that line that my graph gets really close to but doesn't touch? Which one? Y = 0, x = 0. Okay. Are you sure? What's the horizontal line? Y =. I'm going to 100% for sure take off points if you don't have x or y. So then what is my y-intercept? Where does this graph cross the y-axis? At 0, 1, right? So now I need you guys to please help me graph log 3 of x. Well, like I said, you guys don't know how to just do that in your head. So since these are inverses of each other, let's see if we can think for a second.
Well, like, let's say we didn't have a calculator, couldn't we like do with switching?
Okay, good. That's what I want you to think of. Pablo said, well, if we don't have a calculator, can't we just switch it? Right? When we talked about inverses, guys, when we solved inverses algebraically, remember the first thing we did was we switched the place of x and y and then resolved? So all you would do is say, okay, at 1/9 x value, I'm at -2. At 1/3, I'm at -1. I'm at 1, I'm at 0, 3, 1, and 9, 2. So if I was going to graph this, at 1/9, I'm down here at -2. At 1/3, I'm at -1. That's a little too far over. At 1, 0, I'm at the axis, right? Then I'm at 3, 1, and then I'm at, hold on, can't get my, at 2, 9. So I'm going to draw my nice smooth curve, just kind of follow along my dots. So this is reflected over this line, y = x. So if I asked you guys to tell me all the things, the domain, the range, all that stuff, well, my domain and my range. Since this is the inverse, guys, remember, it's the opposite of exponential. So if my domain for exponential is -infinity to +infinity, what's my range for my log? -infinity to +infinity. Those two switch. So if my range was 0 to infinity for exponentials, that means my domain is going to be 0 to infinity. I don't have a horizontal asymptote here. I have a vertical one. So my vertical asymptote, what is the vertical line up and down that my function gets really, really close to but doesn't touch? X equals, very good. X equals 0. Good, Kennedy. And then instead of a y-intercept, what am I looking for? The x-intercept. Where does this graph cross the x-axis? At 1, 0. Very good. Everything just flips. On your quiz, you only have to graph 1, and it's going to be an exponential that you can, you can use calculator or whatever. But I wanted you guys to visually see the difference between these two.
And what's that slope? Like
The yellow line?
Yeah.
That's what it's reflecting over.
would you have to like mark that?
Mm-mm. I just wanted you to see it's kind of like that flip. Okay, we okay on that? All right, let's look at some examples here. We're not graphing this one. But if I gave you this function and I said to you guys, tell me all the transformations. I see 2 transformations. What are they? Okay, it's going to go right 1, agreed. And what else? Not y.
Reflect on the x-axis.
Yep, over x-axis, because it's out in front. All right, you're going to get questions like that, where it's going to say, tell me the domain, the range, the y-intercept, horizontal asymptote, whatever applies to it, and then I'm going to say, name the transformation. So you need to be able to look at that function and tell me it's going to move right 1, reflect over x, just like you would, like you've done in Algebra 2 and stuff. No, you're not going to have to graph it. You only have to graph 1, and it's going to be an exponential where I give you a table of values and say plug this in, and then plot the points, just to make sure you guys understand. So if I look at something like this, I'm going to find the domain, the x-intercept, vertical asymptote, and we're going to graph, okay? So let's just think about this for a second. There's one little thing that you have to kind of think about, but it's not really that bad. But we're going to find the domain, the range. They want to know the x-intercept and the vertical asymptote. All right, what can you tell me right now before even thinking? The range is negative infinity, perfect, to positive infinity, because this is a logarithmic function. Now, going back to what we started with, that first little cheat sheet thing, how do I know what my domain is or where my vertical asymptote would be? Looking at that function, what do I have to do? How do I find that? It's the negative. It tells you on your little cheat sheet to take the parenthesis and set it equal to 0. So when I say x minus 5 equals 0, I know that my asymptote is at x equals 5. So I write vertical asymptote at x equals 5. That directly correlates with my domain. My domain is going to be from where to infinity? From 5 to infinity. Is it going to include 5? No, because it does. That's our asymptote. Now the x-intercept is where you guys are going to have to think for like 2.3 seconds. To find the x-intercept, we plug in 0 for what? For the y. So in this case, f of x equals the y, right? So I'm going to write this down here so we have a little room. I'm going to say log 4 of x minus 5, and I'm going to plug in 0 equals 0. We're going to solve this, and you guys are looking at me like, what? Well, I told you the other day, do we think more as human beings? Do we think more in logs or exponentially? Exponentially. So let's go ahead and change this into an exponential function. How would I do that? Okay, I make the 4 the base, becomes big, and then what happens with 0, and what happens with x minus 5? And 0 becomes the exponent. Well, golly gee, can we figure out the answer to this ridiculously hard equation? What is 4 to the 0 power? 1 equals x minus 5. So what do I do now to get x all by itself? I'm going to add 5 to both sides. So my x-intercept is at 6, 0. Now, graphically, what I need to see from you on your WebAssign, again, you don't have one of these to graph on your quiz. You will have to tell me all of these things, though. But graphically, if I were to graph this, my asymptote is at 5. So 1. My intercept is at 6. And it's just going to come from down here at negative infinity, get close to my asymptote, and then just kind of make a right-hand turn. And there you go. Let's move on. We're talking about natural logs, guys. It's the same thing as a log. When you see ln on your calculator, that means natural log. Look on your calculator. Natural log is on the same button as what? E to the x, because they are inverses of each other. We've already talked about this. The reason it's ln and not nl, people ask me that it's derived from Latin. So those of you who speak Spanish know that when you're talking about like black pants, you say pants black, right? You switch the same thing. That's why it's ln, not nl. But if we're moving along here, guys, I'm not even going to work this one out. You literally would go put in your calculator 2, hit the ln button, and then put 12.5, and then hit enter. If WebAssign tells you to round to whatever it says. But I want to get to this real quick. Exact same properties of logs that we learned Monday, same thing applies to natural logs. It's the same thing. If ln and e are inverses of each other, they just cancel out. So if I have negative 5 natural log of e, what's my answer? Negative 5. When I'm over here and I have e raised to the ln 7, what do you think happens with e and ln? They cancel out, so my answer is 7. That will be helpful when we go on to the next section. All right, people at home, don't leave. I still have like 3 minutes, so don't go anywhere, but I want to do this last problem. Just stay with me, guys. Okay, exact same thing. We treat this the exact same way as we did our logs, because this is a log. If I'm going to find the domain, the range, vertical asymptote, and my x-intercept, what do I know right away? The range is negative infinity to positive infinity. How do I find my vertical asymptote and my domain? I say x minus 3 equals 0. So I have an asymptote at x equals 3, right? So my domain would be what to what? 3 to infinity. How are we doing? Everybody okay? Okay. All right, now the x-intercept, we're going to do the exact same way that we just did the x-intercept when we started off with log, because natural logs and logs have the exact same properties. So I'm going to plug in 0 for my y. So I'm going to rewrite this as the natural log of x minus 3 equals 0. Now, exponentials and logs are inverses of each other. What did I tell you e and ln are? Inverses of each other. So watch, if I say e and then I raise everything up to this exponent, and what you do to one side, you do where? To the other. So I'd have e to the 0. Well, what happens, ladies and gents, when I have e to the ln? It cancels out, so I'm left with x minus 3. And what is e to the 0 power? 1. So now what do? I add 3 to both sides, and I get my intercept is at x equals 4. So it's going to be at 4, 0. Now, hold on a sec. It's super easy now. I know you guys are like, do you just add 1 every time? Well, yeah, when the parenthesis is simple, like x minus 3. Yours are probably going to be like 3x plus 2, where you have to solve, and then, yeah, you're going to have to add to that, so you get a fraction. Question, Andrew? Because I'm trying to get, if you're trying to solve, like if this said, Andrew, the question was, where'd you get the e from? If I had 6x equals 24, how would I get x by itself? I would divide by 6, right? I would do the opposite. So in this case, I have ln of x minus 3. So I need to get that ln to go away. So the opposite of that, the inverse, would be e. So you just put the e, and then you raise everything up to the exponent. What you do to one side, you do to the other side. So e to the ln x minus 3 equals e to the 0, and we're good to go. So quickly, sorry, if I'm going to graph this, I have my horizontal, vertical asymptote, my bad, at 3, right? My x-intercept's at 4, so I get real close here, and then I come off to the side. And there is my graph. So tomorrow, all right, I'm going to post this video as soon as but tomorrow I'm going to answer any web assigned questions you have. If you're looking over this and you have some questions, let me know. I will be available to answer. And then again, I won't be here Friday, but you guys will have a review. So you do it, and then I will post a video. You can watch it, email me over the weekend. We're good to go.